Example 2. The table shows the number X of teachers and the number Y of students in each of several schools. Part A, use a graphing calculator to find an equation of the line of best fit, then plot the data and graph the equation in the same viewing window. Now, remember from our last one that what we're going to Google here is linear regression Desmos. And the reason we put Desmos on there is because we're using the Desmos graphing calculator. So if you have it from our last example, we Google linear regression Desmos and we click on the first link, and it will bring up an automatic populated XY table here. If you already have values, that's okay. I'm just going to come down here and delete them. And then as you go, we're just going to fill in our new values. So we had 10, 12, 13, 16, 15, 18, and then anything else, just delete it. Then we're going to go grab our Y values, 250, 275, 312, 360, 385, and 406. And then don't forget, if you have extra cells, to delete them. And then we need to go find our scatter plot. So if we look at our Y values, they're the whole way up at like 200s, 300s, 400s. So I'm going to move our graph until we find what's going on up here. And then there's our graph, and it looks to me like that's a pretty strong positive correlation. So as the number of teachers increase, the number of students are going to increase, and it looks to me like most of these dots are really close, if not on the line. So from here, we're going to pull our M, which is 20.6, and we could round that to 21, so our slope is 21. Our B value is 42.3, so we could round that to 42. And then it looks like our correlation coefficient, you don't want R squared, you want R, is 0.95, which again, it's a positive, which is telling me this is a positive slope. And it's really, really close to 1, which is telling me that this is a good line of best fit. It fits the data very well. So going back, it says use a graphing calculator to find the line of best fit. So I'm going to say Y equals, remember that our M was 20.64, so I'm just going to make that 21x, plus B is 42.33, so I'm just going to round that to 42, which is going to give us our line of best fit. Identify and interpret the correlation coefficient. That was our R, which is 0.9595, which tells me there is a strong positive correlation. As the number of teachers increase, the number of students increase. And then part C, interpret the slope and y-intercept of the line of best fit. So I'm going to start with slope is 21, which tells me for each additional teacher, students increase by 21. Or you could say that the other way, there's 21 new students for each new teacher. And then we've got our y-intercept, which is 42. Now, that's 42 teachers, or I'm sorry, students for 0 teachers, because this is your y-intercept. Does it make sense that you can have 42 students with 0 teachers? I mean, the students might be okay with that, but I don't think the teachers are going to be okay with that. So this doesn't have meaning. So in the context of this problem, this doesn't have meaning. And the reason is because we're going to say you can't have 0 teachers. If you have students in the building, you need to have teachers with them, teaching them, supervising them.